Okay, so a quick look here, guys, at the pre-leaving cert this year, the Examcraft Pre, question B3. So, as you can see there, it's a cone. Sphere is A on the right and the cone is B. So you're going to be setting that up a 45-degree angle, and the sphere is A. So what you're going to be doing is, projecting that up there, drawing the front view of the sphere, bringing up the left and right and the top of that. So the cone was 80 high, so cone's going to be like this. But to put, then you're going to be asked to put a ball in between the two of them that's touching them. So the solution is going to be a smaller football in the middle there. But to do that, what you've got to do is walk over around here and looking from the side at 45 degrees, put an auxiliary up here. So you're going to be bringing up the cone, bringing up the ball, and we've got to find then, I'll go through that in a minute, how to fit in a ball here that sits on the ground that touches both the other ball and the cone in the center. So I'm going to pause the video, set up all of this, which should be easy enough, and then I'm going to talk about finishing off the question in a few minutes. Okay, so that is the cone, which is B, the sphere, which is A. So here's your cone B, sphere A in the front view. So what I was saying there then is, at a 45-degree angle over here, you're going to want to set up an auxiliary view, project up the sphere, the cone, and draw them above here, pretty much the same as that, but they'll be a pier further apart. Okay, now how do you find the size of a football that sits on the ground, touches the cone and touches the sphere? Well, I'll just sketch it out here. See, there's your cone, there's your sphere out here. What we're going to have to do is bisect the angle there between them. That's a normal bisection. But how do you bisect between the ground and a sphere? Well, it's easy enough, really. Just sketch it in colour here, maybe in blue or something like that. Let's say you come 10 up from the ground. You have to do an arc 10 out from the circle. That's a point. Then you go 15 up from the ground and 15 out from the circle. That's a point. And you see, it's not a straight line. It's going to be a curve. So if I went like 5 up from the ground and 5 out from the circle, you'll see that that's actually a kind of a curve like that. And it's called a locus. So that's what we're going to have to do over here. So I'm going to use maybe I'll go with 10, 15 and 20 for the heights up from the ground and out from the circle. So just very quickly, I'll put the heights on this line here. So I want to go 10, 15 and 20 for heights. I'll put that in a small bit heavier than I would like to now, just so hopefully it'll come out on the thing. So that's up 10, up 15, up 20. So the next thing I'm going to do then is I'm going to come out from the center 10, 15 and 20 and swing curves from the center of the sphere or the ball. So you see 10. Now I could, maybe I should draw these all the way around so you can see. So we're 10 10 out from the ball, 10 up from the ground, 15 out from the ball, 15 up from the ground, 20 out from the ball, 20 up from the ground. And that here is the locus of, because that would go all the ways back into here. That's bisecting the ground and the ball. So then I want to bisect between the cone and the ground, so I always do that pretty big. The bigger you do it, the more accurate it is. So I know that's pretty enormous now, but so that there is the bisect, or between the cone and the ground. And this here is the point we're looking for. Now if everything is accurate, this here is the center, and that would be the radius down to the ground. Now if I set my compass to that, so if I put the compass point there, set it to the ground, this sphere should touch the side of the cone and the side of the other sphere, so that's not too bad. That's not bad at all. So I'll project that back down, and that is my sphere, and it goes, now the sphere is going to go over the cone, but it actually goes under the bigger sphere, so you want to be careful here now. I'm just putting it under the bigger sphere and over the cone, which means I need to rub this out or lighten it a little bit. So because that's after rolling on top of the cone, I'll just dot in the cone here. Then bring it up to the elevation. So we know the height above the ground is this. So again, it goes in front of the cone, but it is behind the sphere. So just dot that in there for being behind the sphere. Like that. So I can now heavy in the rest of the cone. We know what we can see now and what we can't. So that is there, and this, I'll just lighten that off. So that is light. So done, done, done. So that is draw the plan, draw the elevation, show the other smaller size football that is touching both, resting on the ground. The last thing there is to get the traces of a tangent plane to the sphere A and B, and show the point of contact of that plane with the sphere A. Now a tangent plane involves putting the same angled cone above here. I'll try sketching this in a colour. I need to put the same angled cone, so parallel there, parallel here, so that there is what I would call a parallel cone. So obviously it's bigger, touching sphere A. So I'm going to do that over here. Now it is as simple as it sounds. It is as simple as it sounds, and then you just go parallel to the side, to the angle of the small cone, touching sphere A, and bring the other side back down parallel as well. Or you could measure out the base as well if you wanted now, because we know the radius of it, but I'll just go parallel. So that there is a parallel cone. So I want to draw that now in plan. So again, there you don't even need to bring it down really, because that has to be the radius of the base. So Okay, so that's the base radius. So a tangent plane is just touching both of them. So we just line that up there. That's the horizontal trace. And I want to run one point in now. I'll bring in the apex of the small cone, I think. So just bring that in parallel to the vertical plane. Bring up. Bring the height across, so it was the small cone I used. And that's a point on the vertical trace. So that is the second part of it done. Now the last thing they asked for there then is for the point of contact of the plane with sphere A. So where is that plane that we're after drawing in here now? Because we made a parallel cone on the ground. We put in our traces. So we've got a plane like a sheet of glass or metal lying against that. But where does it touch the ball? That's what they wanted to know. Now, one easy enough way of doing it there is where you've got the side of the cone here, like it's 90 degrees out from the center. That's the height of the point of contact off the ground. So if I do that over here, get the angle of the side of the cone, come out at 90 degrees. This here is the height of the point of contact. So I can take that across here because it's going to be at that height, somewhere at that height. But I'm going to bring that down into plan. Roll it around because this is going to be, it's on this circle then somewhere. This circle is at the right height for the point of contact. So it's going to be on that circle, but it's going to be 90 degrees to the trace up from the center. So if I get the angle of the trace there on the ground and just go perpendicular to the trace through the center of the sphere, this here is the point of contact in plane. Bring that up to elevation. That is the point of contact in elevation. So that is the point of contact where, as I said, if I was to sketch this, if I was to sketch that there, it's basically, I won't even bother, I'll just bring it in there closer for you to see. So like that plane, that tangent plane, where's that lying up against the sphere, that's the point of contact. So find the height of it, and that circle there, we'll say that's actually really a circle cutting through the sphere. So we drew that circle down here in plane, and it's perpendicular then off the trace. So that is that question covered completely.